All right, so we're going to take a few notes. Write down whatever you feel like you need to write down. If you don't want to write anything down, that's absolutely fine too. But we need to make sure that you know how to use slope in physics class. Notes, yeah. All right. So let's go ahead and get started. So what I went ahead and did was I just pulled graphs from the internet, and we're going to calculate some slopes, and then we're going to interpret the slopes, and that's really the key. I think for the most part, you guys can calculate slope. But the problem comes when we need to interpret it. So I want to make sure that we're all at the same level, so we're just going to go ahead and calculate it first, and then we're going to interpret it after we calculate it a couple of times. So can you tell me something about this slope? It's going to be negative, right? Do I have to pick those 2 points that are highlighted? No. As long as I pick points that are on my line, it doesn't matter which 2 points I pick. Do I have to pick points that are spread apart from each other? Or can I pick like this point and this point?
You have to pick points that are two different points.
Right. A line has a single slope. So it doesn't matter if we pick 2 points that are close together or if we pick 2 points that are far apart. It doesn't matter because the slope, no matter what 2 points I pick from that line, as long as they are on the line, the slope will be the same. So you have to be very careful about that. I always have students that want to pick 2 points that are really far apart from each other. It doesn't matter. You need to pick 2 points that are easy to pick off of your graph. So for example, if I were looking at this, I would pick this point right here. Why? Because the x is 0. And I really like subtracting 0 from things. And I could also pick like this point. Why? It crosses, right? I could pick one of the points that we have dots for. But as long as I pick 2 points that are on my line, it does not matter which 2 points. So let's go ahead and make sure everybody writes this down. If you don't know it, write it down. Because you are probably going to ask me at some point how to calculate slope, and this is what I'm going to write on the board. So if you don't know that this is how we calculate slope or you don't remember it, then write it down. There is no harm in having to look it up at all. Okay? So this is how we calculate slope. Okay. All right. So now, here's the other tricky part. The problems that I typically see with students. I'm going to use the 2 points that are given for us. Is that if I label one of my points x1, comma y1, and my other point x2, comma y2, that sort of saves us trouble later on. Now I know students typically don't like to do more work than they need to do. So you probably won't put that information on there. But if you put the wrong number in the wrong spot, then you automatically are going to get a wrong answer. And sometimes our points are going to be, we're not going to have x and y on our axes most of the time. But if I know that this point is my first point, and it's x1, y1, then I automatically know where in my formula those pieces go. But I don't have to label them like that. I can label them like this. Is that okay? The answer is yes. It doesn't matter which one is your first point and which one is your second point. What matters is that when you put those pieces into this formula, you do it consistently. So if this is my x1, y1, then both of those numbers have to go in for the appropriate variables that they're replacing in our formula. We do this every year, and I always have students that mess it up, okay? So I want to make sure that we all have the same, we all hear the same lesson to make sure that we all are on the same playing field. So let's go ahead and pull the numbers off of here and calculate the slope for this line. These aren't numbered, so we're going to assume that they're going up by 1 on both the horizontal and the vertical axis. So if we look at this point here, what's my x-coordinate? 1, 2, 3, 4, 5, 6. So 6, comma, how far down do we go? Negative 3. And then what about this point up here? 1, comma, 7. Okay. So does everybody understand where those numbers come from? Seems elementary, but I have people every year who don't know. Okay? So let's go ahead and calculate slope. I'm going to calculate it over here. What value is y2?
7.
Minus y1. Negative 3. Which one's x2? Which one's x1? What do we do when we have two negatives? Change them to positive, right? So what's 7 plus 3? What's 1 minus 6? So what's 10 divided by negative 5? Negative 2. So the slope of this line is negative 2. Did we say from the start it should be negative? All right, now what that means is that every time, because our y's are in our numerator, we're going to go down 2 for every 1 that we go to the right. Did we do that? We're going to go down 2 and over 1. Down 2 and over 1. Alternatively, it could be we're going up 2 and to the left 1. So we start here, we go up 2, we go to the left 1, we're still on our line. That's what the slopes mean. Thank you. Any questions about that? Pretty easy, right? You've all done this before. You have all done this before. But I just want to make sure that we're all in the same place. Okay. We don't have any axis labels on this, and I picked this graph off of the internet on purpose because I just wanted to purely talk about slope and how to calculate slope. But in here, our slopes mean something. So you have to include the units with your slopes. They must be included. I will mark it wrong if it's not because it's just a number. And again, if you want me to be creative and come up with your units, I'll be happy to do that, but it'll have nothing to do with what you just actually graphed. So you must include the units with your slope. That is key to the interpretation. So let's do one with units. All right? Okay, so how about if I give you a minute to calculate the slope? And then I will put my calculation up here. Unless you need, is there anybody that needs me to go over it again? Okay, so take a minute, calculate the slope, and then I'll put my answer up there. Yes? Up? What is it going up by? 20s. It's going up by 20s. What is it going over by? 5s. Thank you for pointing that out, because that's going to affect how we interpret that slope, or how we interpret our numbers for the slope. Okay? I'm gonna start putting my work up here and then we'll talk about it. How many of you got 4? Okay. A very common mistake that I see is that students will flip it. You'll get 20 over 80. Be careful, because it's always the vertical axis over the horizontal axis. Do you have any questions about how I did that? I would like to see you circle the points that you use for slope, so that when I come to check your work, I can look at it very quickly and I can check your work very quickly. Okay? So I want you to start circling the points that you use to calculate your slope. You obviously can't do it with this example, but when I ask you to do this in your notebooks, I want you to circle those points. Okay. So now let's talk about units, because here we have labels on our axes and the units have some kind of meaning for us. I have no idea what this graph is because it has no title. But I know that my vertical axis has cost and my horizontal axis has time. So just let me write the equation up here for slope so that we can talk about units. If I'm looking just at units, we've already figured out the numbers. The numbers are there, we got that, that's not a problem. But if we're just looking at units, in the numerator of my slope calculation, I'm using my vertical axis. So what unit is on my vertical axis? Dollars. Cost is the variable. Dollars is the unit. Okay? So the unit on my vertical axis is dollars. So I have to do the same thing I would do if they were numbers, and I'm going to put that on the top of my fraction. And maybe I should make my bar horizontal. Now, in the denominator of my slope calculation, we have the horizontal axis. So what unit is on the horizontal axis? Minutes. So that, if it were a number, we just put it on the bottom of our fraction, so we're just gonna leave that. Do any of my units cancel? Do I have anything on the top and the bottom that are identical? No. There's our unit. $4 per minute. $4 per minute. So what does that mean? We'll get to that later. Any questions about how we did that? Have you seen that before? Are we all just asleep? Okay. Starting about, how many of you will not be here on Friday? There shouldn't be anything affecting this class, right? Friday is kickoff and band 3rd period. What period is this? Is this 4th? Yeah. Okay, so you guys will be fine. All right, let's do another one. Okay. Sometimes people who are planning for it though are out throughout the day. All right, calculate the slope of this one. Include your units. While you're looking at that, I need to make an announcement that Mrs. Kaufman has asked us to make sure everybody covers their nose and their mouth with their mask, so we need to make sure that everybody keeps that on their face, okay? Do we have it? Need a minute? Okay. Can I start putting my work up here? Ooh, I don't like any of those points. Okay. Is that what you got?
But I feel like it,
Good.
I feel like it has to be a whole number.
Feel like it has to be a whole
Or like
number?
a fraction.
You wanna leave it as a fraction? How many of you wanna leave it as a fraction? Nope. So here's, this is one of the reasons why I picked this graph. Because it's not an easy, like, you divide it out and you get a whole number thing. And I have students every year where you've been told in math class you leave it as a fraction. Right? Have you all heard that? Why do we leave it as a fraction? What's magic about fractions? Uh-oh. Fractions are exact. Right? Fractions are exact. 0.4 is not exact. Fractions, 2/5 is exact. But we don't make exact measurements in science. We cannot make an exact measurement in science. That does not mean we're not careful. It just means that we're always limited by the measuring device that we're using. So our measurements are never exact in science. We can't leave it as a fraction because that would imply that it is exact, and that's not possible for us. So math class, yes, you leave it as a fraction because mathematicians like their exact answers. They're working with numbers. But in science class, we work with real measurements. You can't use exact fractions. Any questions about that? I have students every year that want to leave it as a fraction, and I will mark it wrong because it tells me that you don't understand how our measurements work. So it's really important that you divide it out and always give me the decimal form. So the next question is always, well, how many numbers after the decimal do you need to include? 2/5 is 0.4. So how many numbers do we need to include? Just the 0.4. However, what if it came out to be something like 0.62784133326? Do you need to write every number on the calculator screen? No, because that's ridiculous too. We generally like to have 2 or 3 numbers after a decimal place, unless there's zeros, and then it needs to be 2 or 3 non-zero numbers after the decimal place. That's usually good enough for us. Okay? Now there are very specific rules that if you take chemistry, you will learn that govern how many numbers that we would actually write out. But I'm not going to do that with you guys because it's hairy. I think that's the best word. Would you guys agree with that? Okay. So let's talk about units because I have my answer here. The numbers, we got the numbers, but what about the units? So what unit is going to be in my numerator? Inches. Why is it inches? That's the unit on my vertical axis. And when talking about slope, it's always vertical over horizontal. So it's always our vertical unit over our horizontal unit. So then what's gonna be in my denominator? Year. So 0.4 inches per year. Questions about that one? Good? I'm sure there's another one. Okay. Why are we groaning about this one?
The points are just,
The points are what?
the points make me uncomfortable,
Why do they make you uncomfortable?
because I don't know the exact point.
Oh, yeah,
It's a best fit line, not a.
yeah. So this, I'm not gonna make you do this question, I'm not gonna make you do this one yet. But I put this one on here to talk about for a moment, because I always have students that wanna actually use the points that are given, like the actual points, the measured points. And I wanna reiterate that you have to pick 2 points from your line. Because when we calculate slope, it is the slope of the line, not the slope of our data. That doesn't make sense. It's always the slope of the line. So you have to pick off 2 points from your slope, or from your line. Now, Daisy, does that make you feel a little bit better? Like this point here, and this point here? Okay, yeah. Yeah, so that make you feel better? Your data is not always gonna look nice and neat in a line. The last two sort of set you up for that, right? But your data is gonna look like this. Your best fit line, it might go through a point or two, but in general, your points are probably not gonna be on your line. We are always calculating the slope of the line, because the line is what fits the data the best. Questions about that? All right, so let's go through one more, I think. Go ahead. The slope is 0? Does everybody agree with that? Yeah. So, if we have a line that has a slope of 0, what does that tell us about the line? It's horizontal. Horizontal lines have a slope of 0. So you don't even have to calculate the slope. Unless you think that there might be a real slight slope to this, then you can calculate it yourself. But you see here, most of those points are right on the line. We have one that's a little low, we have one that's a little bit higher than the others. But in general, this is showing a horizontal line. What does this tell us about the relationship? Right, there is no relationship here, because changing the angle does not change the time. Okay? Changing the angle does not change the time. All right, so let's start interpreting some of these. Now we said the slope of this line is 0.4 inches per year. And the title of this graph is fir tree growth. So, all right, let's do this one together. Do you know that any number can be made into a fraction if we divide it by 1? Any number can be made into a fraction if we divide it by 1. So, I'm going to write my 0.4 as a fraction. Are we okay with that? Because 0.4 divided by 1 is still 0.4. I did not change the number at all. I just made it into a fraction to make the interpretation a little bit easier, to make it more obvious what you're seeing. And my units are a fraction as well. So I'm going to go ahead and put the unit in my numerator with the number in my numerator. And the unit in the denominator with my number in the denominator. Any questions about what I just did? All right, so let's interpret this. I'm going to help you out with this one. For every, we're going to start with the denominator. How many? 1, what unit? Year. the tree rose 0.4 inches. That's what our slope means. How do we feel about that? Good? Good? Okay. And that's literally how we interpret the slope every single time. Now, with something like this, most students feel comfortable with this. But when we get into physics, you'll make it harder than it is. We follow the same pattern every single time. We can make this a little bit more detailed. Grows 0.4 inches. How? In diameter. Is there a difference between growing 0.4 inches and growing 0.4 inches in diameter?
Yeah, it could go taller.
Yeah, because when we hear 0.4 inches, when it grows 0.4 inches, we think taller. This is specifically in diameter, so it gets bigger around.
I think it's probably a lot bigger.
Yeah, probably. So what do you think? Pretty good? Not so difficult? See what we got next. Oh, remember I said yet?
Yeah, I don't like that yet.
I love the word yet, just for future reference. So here's what I want you to do. I want you to calculate the slope of that line and then interpret the slope using a statement, just like we did. I'll leave that one up there for you to reference, but I would like for you to calculate that slope and then write a statement giving the meaning of the slope. And honestly, if I were taking notes in Mrs. Foley's class and I've heard she's horrible, then I would probably sketch this graph in my notes, label my axes, there's the line, and then just pull off 2 points and write those points here. So later on when I look at it, I actually have some idea of what I did, because I've got the graph sketched right there. But, you know, they're your notebooks for your notes. If you need to move up closer so you can see, you can always come up closer, look, and then go back and sit down. Calculate it. Are we getting close? Do we have some of you that are done? Stuck? Okay. So where are we stuck?
In the division part, is that on the calculator?
Oh, I'm sorry guys, I should have mentioned, I have calculators on my back counter. You are welcome to use them, just please make sure they get put back on the back counter and I spread them down between classes. So if you need a calculator, go grab one. I should have mentioned that at the beginning, I apologize.
We're going to this, so
What?
we'll go over that later.
Mhm. Isn't that nice?
Does it matter which one's the Y one and the Y two or the?
No, as long as they're consistent with how you put it in slope.
Okay.
Yes. Yeah. I have no idea. That's it? Okay. What time is this class over? 20. Okay. All right, so who's gonna be brave and share? Ethan,
The car value goes down, $0.1, 10 cents every 1 mile driven.
so you got a slope of $0.1 per how many miles?
1.
1 mile. And then can you say it real loud for everybody to hear?
The car value goes down $0.1 every 1 mile driven.
What do you guys think about that?
I got,
You got 0.12? You got 0.12? Sam, you're saying no, what'd you get?
I got 0.15.
0.15, so we got 0.10, we got 0.12, and we've got 0.15. Anybody have something different?
0.13.
My lips go through my face.
0.125, is that what you said?
Yeah, we're talking
You probably have it upside down. You probably have it upside down.
I got 0.13.
0.13? Oh, so you got negative.
Oh, yeah.
Oh, yeah, forgot the negative.
Okay, now I got 0.0.
Okay, hold on 1 second. So, who's right?
Everybody?
Probably not me.
Okay, so, let me share with you a couple of things because, I am notorious for doing this. This is exactly the kind of data that you can expect from me. I am not the kind of teacher that's gonna give you perfectly aligned data ever, because I think that's dumb, you don't learn as much from that. All of your slopes, are they all negative? Did anybody get a positive slope? Okay, so they should all be negative, all right? They should all be negative, that's the first thing. And remember when we were talking about best fit lines, and I said that everybody would draw a slightly different best fit line? However, what should all be similar?
The units.
Your units will all be the same. What should be similar? Somebody back here said it. Slope. The slopes, are those all similar slopes?
Yeah.
They're close. They're not identical by any means, because when we look at that, we all pick out slightly different numbers. But are they all similar? Could we say that everybody probably got around the same value? Yeah, all of those answers for me would be correct. All of those answers would be correct for me. Now, this graph is showing you depreciation of your car when you drive it. So those of you that when you get out of school and you're gonna buy a really big, expensive, fancy car for like, I don't know, $2 million, isn't that what they go buy these days? You spend $2 million on a car, every mile, every 1 mile that you drive it, it's gonna lose value. So, these kinds of graphs is basically, that's how they calculate your, this is one factor they look at in calculating the resale value of used cars. Do you guys have any questions for me? All right, so for the rest of the class period, what I want you to do is I want you to go back and look at all those graphs that you've made in your notebooks, and I want you to calculate the slope and write a statement of relationship. Or, I'm sorry, a statement of meaning for your slope. Statement of meaning for your slope. So pick your favorite graph and start with that one. And know that at some point you'll be turning these notebooks into me, so all this stuff that I'm having you do in class, I will be looking at. I will be looking for. So make sure that you are actually using this time and not just sitting back and pretending that you're busy. Okay? And I'm going to tell you one last thing. On Friday, we're going to do our first lap. I'm excited. I can feel you guys woke up a little bit. I think you're excited too.